All right, everyone, we are back and we are going to do our question number 1 for our practice exam. Whoops. Here we go. And we're going to work with essentially this bag of marbles. So there's a total number of marbles, and that's going to be equal to, let's just add it up quickly here. I'm just going to go ahead so that we know what our total is. Again, I can't do math anymore. So total, let's make that equal to 14, 7, 17, 7, 3. So we have 48. So our total of marbles equals 48. Let's go ahead and read these problems. Put all these pieces in a bag and mix them up. What's the probability of pulling a red piece? So A is red. B is purple. So can I have a piece that is simultaneously red and purple? No. So we're going to do P of A or B is going to be equal to PA plus PB. And our PA is going to be, how many red pieces do we have? Blue, red, purple, green. So it's going to be 17 over 48 for red, plus purple is just going to be 7 over 48. Excellent. What about the probability that of pulling a square or a blue piece? So let's go ahead and we're going to do this. Get rid of this like this. Excellent. So A is going to be square. B is going to be blue. Is there any scenario where I can pick something that's blue and square? Yes, there is. So I need to subtract out probability of A and B happening. So what's the probability I pull a square? So I have 7 squares plus 7 squares. So actually I have 14. 14 over 48. Plus probability that I pick a blue piece, which will be 14 plus 7 over 48. Minus, what's the probability that I pick something that is blue and a square, which will be 7 over 48. And that's it. Actually, excuse me. Probability of A is just squares, which is 7. But we have 7 purple squares too. Excellent. I think I've got it correctly. Make sure. Blue, 14 plus 7. Fantastic. That's it. All right. Let's go to our next problem. So I pulled a piece of the bag, and then I pulled a purple square. What's the probability that the first piece was also a purple square? So we're going to use our Bayes theorem, B of R, given that some event A has occurred is going to be PBR times P of A given BR over summation n equals 1. Or I equals 1 to n, probability of B sub I times probability of A given that B sub I has occurred. So the given event, I pulled out a piece. The piece I pulled a purple. So I pulled a purple square. B, what's the probability the first piece was purple? So I can say purple square. And then B sub 2 could be not purple square. So we have to go ahead and look at those probabilities. So probability of B sub 1 that it's a purple square is going to be equal to what? It's going to be equal to 7 over 48. What's the probability that I pull not? That is going to be equal to 48 minus 7. So actually, let's just get rid of that. 41 over 48. And what do we do now? What is probably the first piece was also that. And then we also have to do, what is PA? So what's the probability that given the first piece was a purple square that I pulled, what's the probability I pull a purple square given that the first piece was a purple square? So now there'd be 6 out of 47. PAB2 would just be equal to what? What's the probability I pull a purple square given the first piece was not? So it'd still be 7 over 47 because there's still 7 pieces. And so then my P of B1 given A has occurred will be equal to P B1 times PA B1 over P B1 times PA B1 plus P B2 times PA B2. Everything's defined. Plug it in. And we've got it. Fantastic. Oops, trying to furiously erase the lazy way. And finally, we're working with some data sets, and we need to calculate our confidence intervals. So I'm not going to do this here. I'm going to actually pull up. Let's move this over. Let's maximize. Great. Let's go to our R code. So let's go ahead. We're going to go to, I believe that, let's go ahead and find, we have some files in our downloads here. So we're going to open this. We are going to set this as our working directory. So we set it as our working directory. We're going to read in these packages. We're going to define our functions. And now I have to define some values. So we are going to be looking at, actually it's probably easier. We have to define some data sets. So let's go. We're finding, we want D1, D2, D3, all this good stuff here. So let's go ahead. So D1 space 1. So we're going to say D1, and then we're going to go say set equal to read.csv of D1.csv. Let's hopefully that works. And it looks like it did. So we're going to copy this, D1, D2, D3. Type that in, type this in. Let's run them all. And we can see essentially what the data set looks like, D1, D2, D3. We can see some values here. Ooh, this is a little bit nasty of a data set. But I'd be fine if you looked at it like this. What you might want to do, and actually I would encourage you to do this. Let's look at this data set here. Let's reopen it and we can resave it. Don't worry, I'll provide you with this really clean data set to make it nice for you. The problem that's happening right now is the data set just starts at a particular value. So I wonder, it'd be interesting. I wonder, we could just do, I wonder if we looked at this. What if we did D1 bracket 1? I wonder if it'll give us that first value that's kind of, so the first value here would be that, nope, it's only giving us the second value. Let's close this. Let's close D1 as well, and let's open up D1 again. Let's have it convert. Sorry, I know this is not super pertinent to you all, but it will be very helpful. So I'm going to go ahead and add in a variable here. I'm going to add in a row, insert, and it's just going to be X. And I'm going to save this. And then I'm going to go to the second one, and I'm going to save this. Because again, it needs that, R always needs those column headers. So, and so if you don't give it a column header, unfortunately, then it's going to mess around with that data set. This is kind of one of the limitations, I think, of R. But again, it's one of the limitations, but again, depending on what you're trying to do, it could also help. Again, when you're sorting stuff through column headers, that's the power of R. So let's go ahead, let's go back, and we're going to go read. Beautiful. And now we can kind of look and see, we get all the data sets and nothing's looking kind of nasty in the column header. So this is fantastic now. So we were asked in the problem for let's just double check, the 90, 95, and 99% confidence interval. And so we're going to do just that. So we're going to do our t.test, and then we're going to do D1, bracket 1, and then we'll just say conf.level 0.9. Oops. Control Enter, and it's looking good here. So what we're going to do, we've done this before, 0.95, 0.99. We can look at it, answer here, answer here. Good. And we can see those values are all changing slightly, and they're widening, which is good. And then we'll do the same for here. So let's go. And all we're just going to change is 2, 2, 2, and 2, 2, 2, oops, 2, 2, 2, 2. And when we do that, so let's do one last look. Confidence interval 1, 90, 95, 99, 90 for 2, 95, 99, and then finally, ooh, I almost made a mistake. It happens. And then finally, 3, 1, 2, 3. That's it. That's your first solution for your first problem. So best of luck, and we'll see you for problem 2. Thanks. Bye.